All right, hey everybody, Big Pete back here again. It's been a while since I've made a video. I've taken a little hiatus from building stuff for a little bit, but I'm trying to get back into my R2 build, and I've had a little bit of problems getting the Teeces up and running. Just had to do a lot of research and figuring a lot of stuff out, so I thought I would make a video showing kind of how to assemble these Teeces. They're labeled as TC 4.0, V 4.0. A little bit of back history on that, right? Because a lot of the stuff that I found on the boards was how to assemble a version 3.2 and earlier, and not much into the 4.0. And so I reached out to some of the original creators and got some information that I'd like to share with you guys before we kind of get into the videos. So the current working model that I think everybody's using right now for TCs is this 4.0 one that was actually redesigned from the earlier 2011, 2012 3.2 version by Devin Olsen. He did a lot of work onto these PCBs to make them for one cheap. You can get three, you get 5 of each of the boards you need for like $28. So it's very easy to, very cheap to get them. And he fixed some of the inherent problems with the original version that John did. Had a trace issue internally into the PCB, as well as these newer ones. The pads where you actually solder everything onto, they got larger as well, so it actually makes it a little bit easier for soldering, and a couple other things. So we're going to start off by doing the RLD. I already have one built out, and I've built one of everything that we're going to be building already, but since I wanted to do a video, we're going to be starting from scratch and redoing the RLD along with the pies and the other guys. But before we start off, I wanted to kind of explain some of the things that we're going to be using in this video, some of the things that I think would be helpful. Right here, this is a set of helping hands. I got it on Amazon, I think like 30 bucks. I got myself, it's branded Merci. It's a soldering station, super handy. If you don't have one, again, I think I spent 30, maybe 40 bucks on this soldering station. It works fantastic. It had extra tips with it. It heats up very fast. It has a nice little holding spot for it. So compared to your just rinky-dink ones where you're not really sure what temperature on-off settings, this thing is very precise for what it is, and it heats up very fast. It made doing this project a lot easier. So I would definitely recommend getting that. I'd recommend yourself a set of helping hands. These ones are magnetic. I found it pretty cool because it had a bunch of different attachments and stuff, but in reality I really only use like 2 hands. But if you have one that's smaller or larger or whatever, it just helps to have a pair of hands that can hold on to something. I got myself some rosin. I started using it. I ended up really not needing it because the solder I got is rosin core, and it works just as well. This is a 0.8 millimeter hollow core rosin core solder. I ordered on Amazon, fairly cheap. This is a desoldering gun. It's very simplistic. I think it came with my soldering station. You just push down the plunger, push the button, and it kind of sucks the solder right back out. So I had to desolder a couple of these boards a couple times because I learned as I go. We're all not electronic engineers and too great at soldering. So I've gotten a lot better over the last couple days of me just playing with things. But I did have to use this a couple times where I messed up a couple leads and soldered actually this entire thing backwards. And I'll get into that as well when we kind of start soldering the LEDs. There's a parts list online. I got it printed out right here, but you can find this online on the forums. It covers all the different things you're going to need other than just the PCBs, headers and what LED colors, the types you're going to need, the different chips that you'll need, just everything that's in there, it's all covered in there, so I'm not going to go over all of that. I will tell you, I got 98% of the stuff that I am using in the build, with the exception of like the soldering station and this. I got on AliExpress. It took 2 months to get here, but I got it for a quarter of the price, and I got double the amount because I knew I wanted to shoot a video on it anyway, so I probably need double the amount so I could do one and then teach you guys how to build another one. So I was able to get it super, super cheap. I did order extras in the event that something was faulty. I've heard that these, or the Max 7219 chips have had problems from China, so I ordered a ton of them. I think these are $10 a chip, I want to say. If you get it here in the US, I paid like $1 for these, I think. So I ordered like 20 of them. And I haven't actually had a problem with any of them so far. So I thought I did. I didn't, but I have extras in the event I needed them. The same thing with capacitors, right? I ordered a pack of 100 capacitors, 100 resistors, you know, as well as all of the just everything that goes into this thing. I did not put a lot of money into it just because, since I was willing to wait the couple months for shipping, and it turned out pretty good for me. So if you have nothing but time to spare, the Chinese alternative will save you some money. But if you really want to get the exact parts you want at in a reasonable time, I would definitely use a U.S. supplier. DigiKey is where I got some of my stuff off of. There was a couple parts I could not get on AliExpress, like these capacitors, or these capacitors right here. It's the 10 UF capacitors. I couldn't find those at AliExpress, so I got those there, along with the 28K resistors. I found 24K, couldn't find 28K. So anyways, so we're gonna get started into this. All right, so before we get into the building of this, I wanted to kind of just go over some of the history and clear up a little bit of the versioning that you see in here, and I found that a little bit confusing. So I was able to reach out to Paul M., as well as Devin Olsen, who are some of the creators of these Teeces, along with John Vannoy, who was the original creator, from what I found for the original Teeces. His username is actually TC, and what happened is, back in 2012 or so, they started working on Paul and John started working on the Teeces 4.0, which is not what you see here. The 4.0 is actually mostly surface mount technology. What it tries to do is it tries to cycle the colors rather than what you see here, which is just on off, right? These little chips right here, these are your LED controllers. They do not allow the LEDs to fade in, fade out, to replicate the original technologies that went with R2-D2. So if you look back at the original, how R2-D2 was created, right, they didn't have all of this technology. So what they had was fiber optic tubing wired down with a rotary wheel of color. So as the rotary wheel would spin, you would get the different lights displaying through the holes of the fiber optics. So it would fade in, fade out, and be more, I guess, natural, right? Not so much on-off binary, but kind of give R2 this real life, right? How do you make a Android express emotions and express feelings? Well, let's try and make it not so ones and zeros, but let's try and make these kind of fade in, fade out, these colors with them, so that he can gain some more life. The Teeces 4.0 eventually evolved into what's now known as the logic engine. And if you are interested in getting the logic engine kits, Paul does offer kits for those currently. They're more complex than these, and they're not so easily open sourced, right? Everything you see here is open sourced. Like I said, I got everything off of AliExpress. It is very cheap. It takes a little while to set them up and solder everything, but it's a very cheap alternative to the more complex logic engines, which are fantastic lighting systems. They look great. They did a fantastic job with them. But this is more for the hobbyist. You know, hey, I want to do something on my own. And these Teeces, 4.0, but really it's more of like a 3.3 TC, because the 4.0 is really what evolved into the logic engine. But not a ton changed when we went to this one that Devin created. He resolved a couple of the issues where in creating the boards, I guess there was one lead that would short out because it wouldn't always translate through the manufacturing process. So you sometimes would get a good one, sometimes get a bad one. And he eliminated that by retracing basically everything inside of here. So he did a better internal design for this guy just to clear up some of those problems, as well as he made it a little bit easier to solder. But for all intents and purposes, you can follow most of the directions for the 3.2 with this 4.0 TC. So, all right, so we're going to get into the build, and I'm going to kind of explain some of the things you're seeing on the board.
All right, so we are now looking at the RLD. This is the larger of the displays. It's recommended that you start with this one because everything's powered off of it. I actually started on one of the Pis and then found out I had no way of telling if all the LEDs were working right, and so I kind of hamstringed myself there. I definitely should have listened to the advice on the forums and started with the RLD. So as we're looking at the RLD, I got a little bit confused on what these pins here were actually doing. These were actually first thought of for an AT Tiny 85, which were thought to be a good cheap alternative to the Arduino Pro Mini. And the little 6-pin header right in here was actually used to program that. But nowadays, the bootlegged Arduino Pro Minis, they're so cheap that the Tiny 85s really don't make any sense to use. You could still use them in these slots, right? So it would take up this space right here, and then you would use these to program them. But the Pro Minis are just so cheap that would fit into here that it really makes no sense to go through here. Another couple things that take a little bit of just explaining. So right here you're going to see two terminals and they're labeled raw, right? So that would be for raw power coming into it. So if you stuck your power adapter into here and you didn't want to down convert your power to 5 volts, you could stick a 12-volt source on this. And if you use that, you have to also use these 3 areas right here for a 10 UF capacitor, a 1 UF capacitor, and then a L780, which is actually this guy right here. The feedback I got from a lot of people is that using the raw power is not very good. It drains a lot of power. It's not very power efficient, as well as it just generates a lot of heat. And with how cheap you can get just a 12-volt converter, to convert this down to 5 volts, it didn't really make a lot of sense to use that. So we're not going to even solder in any of the stuff for the raw power. So you don't need to put anything here, or in the raw terminals. The things that we will be using though is a 28K resistor right here. Again, the 28K resistor I had to get off DigiKey because I could not find that one source through China. As well as we're going to use one of these terminals right here for our 0.1 UF and our 10 UF capacitors. It was recommended that you use the middle ones. You don't need one for every single row. You just need a set one. So do a 0.1 UF here and a 10 UF right here in these two and these two, and you'll be good to go. in all of these slots right here, all you need is, let me find it real quick, just some pin headers. So this is a double row. You could use a double row and a single row right here if you wanted to. You just kind of cut them to what size you need. So this is a double row. And then they also come in just single rows, so you can just cut whichever one you need to size. Stick them into there, solder them. That's it for this side of the board. Oh, and actually one more thing. So another thing we're going to use right here is just a socket, right? So this socket would fit right into here to fit our controller, as well as this. So this is a wide one, and then we also have narrow ones that we'll be using for here, and here for the LED controllers, which are these guys right here. On the other side of the PCB, this is where you're going to be soldering all of your LEDs. So the LEDs go on one side, most of the control hardware goes on the other side, and as well as the capacitors that go into the center slots that were right here. Those are also going to pop out the back here because we need to be able to fit our LED controllers on this side. So I actually have my fully finished one right here. As you can see, all the LEDs are on that side we're looking at, as well as our capacitors, our 0.1 UF and our 10 UF capacitors. One thing to make note of is make sure you don't mix match your capacitor types. So these are the aluminum capacitors, and then there's another type of capacitors that just kind of looks like these guys right here. Don't mix and match those. Make sure that you get your, so this is a 10 UF, 0.1 UF, and these ones are 1 UF and 10 UF. So make sure you don't mix and match those. You will need to use, if you're using the raw power, you will need to make sure you use these big guys instead of the little ones in those spots that I told you earlier that we won't be soldering these 3 areas right here. So just take that into consideration. If we flip the board back over, you'll see we have our terminal for our 5 volt. We have our Pro Mini right here. And this is kind of what tells all the LEDs what to do. If we didn't have this in, you might get power to some of the ports. If it wasn't programmed, you won't get power to any of the ports, and we'll go over that a little bit later. But you have to make sure this thing gets programmed as well, and it just comes as a blank chip, and you got to solder kind of all the leads onto it. These are our LED controllers. Each LED controller controls basically the segment that it's looking at right here. So this LED controller controls all the LEDs in this section, the middle one, the middle section, and this one in the other section. So if we find out that, hey, some of the LEDs don't work in a certain quadrant, we might want to look into replacing or reseating. These guys can tend to help a little bit if you're having issues. And that's why it was also recommended to buy a couple extras, especially if you're going through the Chinese route, because sometimes these ones don't function well or are faulty in general. So, all right, let's go ahead and get started. How we're going to kind of start with everything, I have, if I turn my camera over here, I just have a 12-volt battery with a couple leads coming onto it, and then I have a regulator, so I can regulate the power going into and out of the PCB. So if I was to turn it on, all my lights start turning on, and then I can regulate this. So as you can see, it's getting 5 volts out. One thing that it's not necessarily needed, but I would definitely recommend having is some sort of multimeter, just to be able to test voltages out, make sure things are working as intended. It's nice to get a actual backup of what you're outputting, or if you're having problems with certain LEDs not lighting up, you can at least start to diagnose, am I getting any power, am I getting low power, and going from there. So here's how we're going to start off with everything. Would be our down converter, or some way of providing yourself 5 volts. Again, I got these off of AliExpress for a couple dollars. I ordered like 5 of them because I didn't know how well they would work. This one works perfectly. I've been using it the whole time, and it works great. So I'm going to go ahead and turn off the power to that. And we're going to start off with the actual soldering. All right, so here we go.
All right, so I've set everything up and got everything ready for this. How I have been doing this is I've actually been using my helping hands to hold my solder because I find it easier to maneuver everything on my board free-handed. I'm going to go ahead and heat up my soldering iron to 600 degrees Fahrenheit, which works really well for this. I use about 350 if I need to desolder anything, or sorry, 650 if I need to desolder anything, and about 600 for soldering anything. And again, I'm using rosin core 0.8 millimeter solder. So I just turned it on and we are already up to 600 degrees. It powers up very, very fast. I actually don't need it quite just yet. So we're just going to start placing components on. Soldering takes a little bit of getting used to if you are not if you've never done any soldering projects before. This is a pretty good way into it, and I've learned a lot of just helpful techniques over the last couple days of me building these things. This will be my second one of these that I've built. So, but have definitely had some issues getting everything working on it. So we got everything through, and what we're gonna do is I'm gonna explain kind of how one of the things that I found very helpful with soldering is like I said, I use my helping hand to hold my solder in a position I want. And what I want to do is I want to have the lead of my, so like let's say I was soldering this lead into something. I'm going to make kind of like a little cross right here with the component and the soldering tip. And then right in the center is where I'm going to put that the solder, and so it will basically just fill straight into where I want it to be. So you make a little Y, and then you just touch it to it. So I just kind of go down there. So I hold my little Y right there. Oop, if I can get it right. These holes are a little bit larger, so they need a little bit extra solder compared to some of the like the LEDs and things. But you can kind of just work your way down. Make sure you don't have any bridging. Now, when I say bridging, all it's referring to is extra solder spanning a gap, right? So making a bridge of solder between 2 points. You want to make sure that you keep all your solder on the one position that it's supposed to be on. If you don't, you can end up having shorts, you can end up having fires, you can completely ruin a piece of electronics. And some of this stuff is a little pricier than others, especially depending on where you source it from. So make sure you don't boot anything up. Make sure you pay attention to how you are soldering everything. And if you have any bridging, just get rid of it by, you just kind of clean your soldering tip and kind of maneuver some liquid solder around on it. One problem I did have early on with learning kind of some of the better techniques with the soldering is to make sure that I use enough solder to actually create a good point of contact, right? So if we look at this, you can see there's a little almost a little mountain that's made between the contact and the point here. So just using enough to make sure that it's contacted well, but not too much that you create a bridge, because that's bad. All right, we were just about there. All right, so that was the first little bit of it. That's all soldered on and good to go. As you can see, it went pretty quick. I'm going to pull a little bit more solder through. I really like using the solder with the helping hands. It works really well. Next thing we're going to do is I'm going to stick on our leads for our ins and our outs. These are where our other lights are going to get plugged into eventually. So again, I said you can use the double rows or the single rows. I'm actually going to use a combination of both because I have a lot of these double rows and not a ton of single rows. So I'm going to go ahead and cut myself off a section of 5 of these guys. And these are just some regular wire snips. 1, 2, 3, 4, 5. I tried a razor blade on this and I ended up getting kind of a weird chunk that came off of like the end right here. And these just work significantly better. I just have a pair of snips. And I'm going to cut myself a single as well. 1, 2, 3, 4, 5. Make sure I'm not cutting the center. That would be good. And there you go. All right, so with these guys, since they're going to be on this side of the board, we want to make sure we use the small section of it to put it into the board. So we want the larger section kind of hanging out. And I'm just going to stick these into their respective slots, as you can see right here. And then I'm going to do the same thing I did over on the other side. I'm just going to solder these guys up. One thing you might notice is I'm not using an ESD band. Shame on me, I'm risking it because I don't own one. I didn't want to buy one because I'm stubborn, I guess. I would recommend using one, absolutely. So you don't want to short out any of the components you're using. All it does is hooks your body up to a ground, so your the electricity in your body that you might conduct with static electricity or something does not go through to your workpiece and short out any of your components. And in general, is a good idea for using for computers and things of that nature. Okay. All right, those are all soldered on. Oh, you know what? And so see, this is what ends up happening sometimes is they're not quite straight. That's kind of a pain in the butt when it comes to these fibers. What we end up having to do is melt the solder a little bit and slowly put it back into place. And that is definitely a bad on me, but it is fixable. Is it the end of the world? No, not really. But it's annoying. And you're going to make mistakes when soldering, especially if you are a amateur solderist like I am. You'll make mistakes. But as you can see, most mistakes you make while soldering are fixable. So that one's nice and fixed, and I'm happy enough with that. We're going to go ahead and do our next bit, which is just putting on... actually, this is very important to do it in this specific order, is to put in your capacitors first, because these capacitors are going to go into this side of the board, and they're going to be covered up. So if you want to ever be able to access them again, I would use single pin or single row headers instead of double row headers, because it makes it almost impossible to get through even those little slits right there to desolder something like this. You're going to end up ruining this guy. Which I did a couple times. I ruined a couple of these because I mix and matched my capacitors before I knew better. So I'm trying to save you guys the hassle of that. All right, so make sure you line up the right, 0.1 UF to non. These type of capacitors don't have a positive and a negative, so you don't have to worry about the positive and the negative. Mind you, if you wanted to know, the negatives on these boards are all squares, and the positives are circles on everything except for the actual LED sections. So if you were using a different type of capacitor, that's how you're going to tell your positives from your negatives. So we'll go ahead and take our 0.1 UF capacitor, and we're going to solder that guy right into there. And I leave that guy flush to the board. There's no reason to have it off the board at all. You're just going to stick it right onto there, and it's done. It's going to do its job. If I can do this right. Problem is I'm trying to do it with my non-dominant hand. There we go. All right, so that one's in. We're gonna do the next one. So one of the things you might see with these guys is when soldering these guys in place, this is a little bit smaller than the hole is. I don't know if I can show you quite that,
but this does not quite line up, right? It doesn't go through the hole. It's a really easy fix. All you need to do is just get a pair of pliers or something and fix the way that it's bent and bend it the way that you kind of need it to. Just be careful of damaging the actual capacitor, because we need these things to function. So you just kind of bend it out a little bit. If you want, you can bend it back into the fancy little shape that it was in, but it doesn't really matter as long as it goes through the holes and they contact right on the other side. That's all that really matters with these. And again, there's no positive and negative in these ones. In mine, at least. Yours may say it has a positive and a negative, but in general, these type of capacitors don't. So, all right, so I got it through the hole. Go ahead and solder it in. Okay, I'm happy with that. And then you're left over with these kind of longer leads coming off of it. You can use some straight snips. What I've been using is cheap fingernail clippers. They work really well, and you just snip those off. And we're left with a pretty decent looking solder, I think. Is it the best? No, but I'm not a professional either. So. All right, so now that we got all of those soldered on, I'm going to quickly solder on my terminal to give myself some power. They make these guys in bigger, larger ones. Get the green ones, the smaller ones. I bought blue ones originally, and they're not the right size for it. So you just kind of push that guy in, and that's where we're going to be getting power. Then quickly solder it in. And once you're happy with that, we're good to go. All right, let's go ahead and throw our controller standoffs in. And if they're bent out the wrong way, like I just dropped one, just bend the pin back. Just be careful with it. They're actually somewhat fragile. At least the ones I did, the whole thing's fragile. One quick thing to note, which I definitely didn't look at first, is there is a little groove on your PCB right here, a little 3-point ring right here, if you would, and that you need to match up. Not necessarily with this, but it helps. There's another little notch you'll see on there. Just line those up because if you put your LED controller in wrong, that will definitely not make it work. As you can see, there's a little, on my middle finger, you can kind of see there's a little notch right there for it. So line those up the right way the first time and it'll be better. So again, I'm talking about a lot of the things that I messed up my first time. So if you do it, no big deal. Just either hopefully you got extras or you're pretty good at desoldering. I found these things are fairly hard to desolder. I ended up ruining a couple of them trying to desolder them off my first board because I didn't line them up right, and I'm somewhat of a perfectionist, so I wanted them to be nice and lined up. All right, so my video crapped out a little bit, but I went ahead and soldered the next one in, so I'm going to work on the third one. One thing to consider when working around any of your other components in this build, so like the capacitors, is to make sure you're wary of where the tip of your soldering iron is so that you don't end up scorching any of the components you don't want to. The first time I did this, I messed up a couple capacitors because I was not being careful of where the back end of my soldering iron was, and I scorched a couple capacitors. So I ended up removing them, putting them back on. But by the end of this, I think you'll learn a lot about soldering. You'll learn a lot about how these electronics function. And I hope you have a good time with it, because if you're not having a good time doing this hobby, you might want to look into doing something you more enjoy. Or if you don't enjoy this part of it, I know there's a couple builders out there that might build you one, and you can do the parts that you do like. But I enjoy hobbies, and this is fun for me. All right, so we got all of those put onto the board, and our board is, oh, nope, actually we forgot one thing. We forgot the 28K resistor. All right, there we go, found my 28K resistor. Again, these guys are really easy. They just come in a long strip. You might get them in a different kind of pack. You just kind of bend them where you need it. That. And then you put it back through. Again, these guys do not have a positive and a negative, so it doesn't matter which way you put it through. Just kind of stick it in and get it to go in the hole you want it. And there we go. It's in there. It looks pretty flush. And then we're just going to solder it in place just like we've been doing everything else. If you want to make sure it kind of stays in the orientation you wanted it in, you can always just kind of bend the wires a little bit first before you go ahead. Pull through a little bit more solder. And take our snips, snip them off, and there we go. That, let me double check it real quick. Yep, that is everything we need soldered onto the board, with the exception of the LEDs. So the next thing we're going to do is we're going to, I'm actually going to turn this off. Turn my soldering iron off because I don't need it for another couple minutes. And then we're going to put our LED drivers in. So mine again came in just kind of wrapped up all janky like, but again I got these really cheap from China, and you get what you pay for. They work, and they only cost me a couple dollars a piece rather than $10 a pop, I think is what they were costing before. Now when putting these guys in, again, pay attention to the little key right here. I can get that in the light right, which is a little half circle. Make sure that lines up with the half circle on the board as well, because that does make a difference when doing this. I'll take that and I'm just going to make sure everything lines up, and I'm going to push it into place. And that's it. Now we need to make sure we get all three of them for this board. The rest of the boards only need one each, but they will only drive so many LEDs. So this one has a butt ton of LEDs, and it needs a good amount of controllers for it. If your pins are off a little bit because of the way they stack it, you kind of just very gently push inwards on them, and it will line those pins up the way you need them. And make sure you got it seated right before you continue. There's two. See if the third one goes in any better. Make sure we line up our key. And all three of those are in. All right, so now that our board is pretty much ready for the next step, we're going to set it off to the side, and we're going to go ahead and grab our next little bit. So when you get these online, these are the Pro Minis. They're going to come usually disassembled, so you don't have any leads coming off of this, and it's just basically the Pro Mini. But it should come with a couple of your single row headers as well, and if it doesn't, Hopefully you have some more of these anyways from other things. What we're going to do is we're going to again take the shorter end of the header, and we're going to just pop it through like that. So just a little bit's coming out. What I have seen some people do is they'll push these through. So these things are not solid into here. You can actually take this pin and push it up, and so it'd be more even on either way. I have seen that done on these in the event that you need to use the opposite side of the Pro Mini for some reason. You would just push it up and you'd leave those leads hanging out of there. One thing that was recommended was to, when you get this guy, is to put it inside before you start to put the chip in, before you start soldering, just to make sure everything's nice and lined up and that everything fits in there perfectly. So I went ahead and inserted it into here, and then we're going to start soldering everything up. I did a couple of leads off video because I didn't realize my video shut off, but it's the same thing we've been doing this whole time. Just make sure that you are being very aware of where the rest of your soldering iron is, so that you don't ruin any of the components in here. And then once you're happy with your soldering job, you get to start programming it. All right. So for this, now this is it. This is what you're gonna have before you start putting LEDs in, and this is ready for LEDs. One thing we have to do though to get everything to flash in the right order is we have to upload our control software to the Pro Mini. Without that, everything will kind of get power, but it's not going to be enough power to actually do anything. And you might, if you put an LED in backwards, it might give it enough power to brighten up, but this is actually what's telling everything to do what we want it to do. Since this doesn't have a controller, you're gonna have to make sure you get something to be able to control this as well. And I have that right over here. All right, so here it is. All this allows us to do is plug a USB into the board and to be able to program it. Now, a couple ways to do it. You can use what was included in mine, and you can solder this actually onto here, and then use a jumper cable that you've made to be able to jump from the pins on here to the pins on here. One thing I saw online somebody do is literally just line up the pins the right way, plug the USB in, and go from there. Paying close attention to what goes where, right? So very, very small printed inside of here, you'll see DTR, it's TX, TXD, RXI, and so forth. So as long as you match those up right, you should be good to go. So it'd go like this for that. And then we plug our USB into it. So we're going to go ahead and do that. We're going to take our chip out to program everything on our computer. And it should go pretty quickly. This is the second time I'll be doing this, so we'll see. Make sure you don't do what I did and freaking bend a pin. Hopefully it bends back, and it did. It bent back, and I bent the other one too. That's why it's important to pull it up from both sides at the same time, so you don't do that. All right, I bend it back in, and we're good to go. So we're going to take that, we're going to take our USB cable into that, and program on our computer. Okay, well, we got everything hooked up. We got our Pro Mini on our USB. We have all the lights are all blinking and everything. So we're going to start off. If you don't already have the Arduino software, go ahead and go to the arduino.cc, download the current version, and then go ahead and install it. Once you have that, we're going to go over to curiousmark.com. Curiousmark has a bunch of tutorial stuff on doing the Teeces, and there's some information on how to upload all this configuration on his website as well. But I'm going to run you through just a real down, dirty, easy way, because parts of his tutorial confused me, and I think I have a little bit easier of a way to explain it. So what you're going to have to go do is go to this section right here, the sketch downloads, and download the sketches. Go ahead and download both files. You're going to need both of them.
But go ahead and unzip the Teeces Curious Mark 1.4.zip. Go ahead and extract that and open up the file inside of there. All right, now that you have the file open, we're going to go ahead and make a couple modifications to the coding in here. First, what we're going to do is we are going to include library. So if you look at Curious Mark's website, it goes through kind of it confused me at first, but a confusing way on how to set up the files and set up the folders to be able to have the library included. A much easier way of doing this is literally go to include library, add a zip library, and then go ahead and just select the Teeces control.zip file and hit open. It'll import it if you don't already have it imported like I do, but you'll be able to verify that it's in there by if you go to include library, you'll see it down here under contributed libraries. You'll see TC control. So once you have that imported in libraries, and once you have this, the Curious Mark 1.4 open, you're going to go scroll down just a little ways and you're going to see this section right here. These are the variables that you'll need to set prior to uploading anything to the board. So for us, everything with the default was good for us, right? Because one was a Pro Mini, which is what we're using. PSI type was 4, which is the V3.2, which is also used for the labeled 4.0, which I like to consider more of a 3.3. But this is the one we're going to be using for what we're doing. Leave the baud rate at 2400 unless you know what you're doing. If you know that your control needs something different, then set it to that. But for the purposes of this video, we're going to leave that default at 2400. Right here, these 3 lines, if you want to modify these are the startup scripts that each of the lights are going to display when starting up. If you just remove that text in there as well, it makes the startup a little bit quicker so you can diagnose flashing issues without having to wait for the scroll text to go through. So once all of that is good to go and you've made all the modifications you need to make, gotten the library, make sure you go over into check your port. So what COM port you're on, what USB port you're on. For me, it's 9. If you need a quick way of determining what COM port that is, figure out which ones you have right now, unplug the Arduino, and then look which ones you're missing. Mine's 9, and that's just a really silly way of getting it, but it works really quickly. So I'm going to select 9. If you want to click board info, it'll tell you that, hey, there's a board connected to it. If you have the wrong thing in there, it'll error out. So, but I got one connected to it, and then all we're going to do now is just click upload. So it's going to compile and upload everything to the Pro Mini. What you should be seeing right now is some green flashing lights on the USB controller, and all that's saying is that it's doing it's compiling something to the board. So right now, what you can't see is I'm holding both chips together so that all the metal leads are touching right. The first time I did this, I actually soldered the connectors onto the Pro Mini and then used a jumper cable, but I wanted to test it this way, and it works, but only if I'm holding it just right. Otherwise it errors out. So take that as a heat of warning, but it works both ways. So we're done now. I am going to go ahead and unplug it, and then we'll get back over to the bench. As you can see, we're done uploading, and that's all we need to do for that.
Okay, now that we got our chip, it's all programmed and everything, we just grabbed it off. This now will control every piece of lighting that we put into the dome. So we're going to go ahead and plug this into the chip here, into the RLD, sorry, and go from there. So all we're going to do is we're just going to line up the pins, push it back in just like we had it out before, and now we're good to go. So this guy, for all intents and purposes, is ready to put lights in. Now, again, I went the cheap way of buying LEDs from China, and I could not find any that didn't have the flanges on them. Let me go ahead and pull one out so I can kind of show you. Ooh, that's not going to focus right. But there is a little lip on the edge of here, right? So it's going to make it so that they don't bunt up next to each other so well. Well, this one's not non-flanged because I already unflanged it. But the flanges, they'll bunt up next to each other, and so they won't go directly next to each other. In some cases, depending on how big your flange is, could cause issues because these guys are really, really squished in there. I'll show you my finished one right now. They're really squished in there. If you have flanges on them, it's going to mess things up. So what we're going to go ahead and do is we're going to deflange a ton of LEDs. It's kind of a pain in the butt thing. I've seen people do it a couple different ways. One way is they somehow mounted a washer onto their soldering iron. The way that I did it is I just grabbed like a very simple wire connector that would barely, well, not barely, it would just fit the LED, but would not fit the housing, right? The flange. So it goes straight through here, but it gets stuck. And then all I have to do, since I'm using this, is I just stick this at the end of my soldering iron. Get a better view of that. And then all I have to do is heat the soldering iron up, and I push through my LED. You gotta be a little careful with it, because once you take some of the flanges off of these, if you aren't very careful with it, you'll actually take off where it needs to grip onto it for the LED to work. So I'm gonna go ahead and heat up my soldering iron real quick and do a couple of these on video. It's extremely boring and it takes a while, so I'm not going to bore you with doing them all, or maybe I'll speed it up. I'm not 100%. Oh, nice thing about this soldering iron kit that I got is it goes into standby automatically, which is fantastic because I left it on for the last hour and a half and it went into standby mode. So big bonus on such a cheap product. Great work, Mercy. All right, get that back in position. All right, so I also upped the temperature on my soldering iron to about 650 for this one, just to, I think it made a little difference. Whether it did or not, I have no idea. And if you have a better way of doing this, this is just the way I did it. It's what I had in my house. I wasn't going to buy anything special. It's just something I found that worked for it. If you find a way that works for it in your house, go ahead and do it that way. I think some people tried snipping it. I don't know how I feel about that, but this is how this one works, right? So now that everything's up to heat, we just kind of put it in there and you'll slowly see it starting to disintegrate. And you get it through, I twist it back out, and the flange is gone. And then I do that for the next, I don't know, 200 LEDs or whatever, because you're also going to need to do this for all of the white and blue ones as well. So as you can see, this takes a while, and it's not very fun. So I stick a show on in the background, and I go from there. And just kind of monotonously do this while I watch a show with my wife or my kids or something. It's a good passive time. So you can see there, I just did 4. I'm not going to bore you with the rest. We'll come back when I have all these done. All right, so it's about 50 minutes later. I've deflanged successfully. God, what is it? About 150 LEDs or so. As you can see, the shrapnel from all the LEDs. But I got a bunch of LEDs that now have no flanges on them. So now we're ready to solder in the LEDs. What I went ahead and did is I connected my 12-volt battery again to my my down converter. So as you can see, I hit a button here. It'll tell me how many volts is I'm getting from the battery, which is 12.4. How many I got out. Right now it's 0 because it's off. And then I can just turn it on and it gives it 5 volts. And now if I was to measure the voltage coming into here, I would show the appropriate voltage. So here's one side of it, just got a single red light from the Pro Mini, and we are ready to start soldering up the LEDs. So let me get that set up. All right, so I'm ready to go. The way I'm going to do this is I'm going to do it row by row. So I'm going to have it oriented like this. If you take a look at the photos of the colors and everything, just pay attention to the orientation of the chip to where the colors go, so you don't end up going backwards. Not that that would really mean a whole lot. It would just mean your colors are flipped, and no one's ever going to pay that much attention in the first place. So if you have red here instead of red here, you know, nobody really is going to
care or pay attention, but if you're nitpicky, pay attention to the board orientation. But we're going to be doing it row by row, and all I'm going to do is I'm going to take my little sheet and go row by row and put them in. So I'm going to start with a red, and one good thing to do before you start everything would just to be to test the LEDs out in the different slots to make sure you have power going to the whole row. So if you want to take a just one LED and put it into the slot, make sure that it starts flashing before you start soldering everything. This one is actually flashing, it's just not super bright. There it goes. Make sure it's flashing in every port. You can take one LED or two LEDs or whatever and test each one, just to make sure that you kind of got it through. As long as you're doing a couple segments, you should be good. Make sure no segment of the board is out. But it's flashing. One other thing that I did mess up my first time, and I actually saw another user do it recently as well, is they reversed the polarity on their LEDs, and it's very important. You see there how there's a short leg and a long leg. It's very important to get this correct, because if you don't, you end up not having flashing lights. You have super bright lights that just kind of get dim. So you see the difference in these two lights? That one's super bright and kind of flashing. You can't really see it on the video, but it's just kind of dimming in and out, when the other one is actually fully turning on and off the way that it should be. So if you run into an issue where you're like, hey, these aren't really turning on and off like they should, it's probably because you have the polarity mismatched. So on the boards, or on the LEDs, the long lead on it is going to be your positive, and the short lead is your negative. And so you're just going to match your positive end up to the little dot right there, or I believe it's supposed to be a positive sign. Just match those up, and go ahead and pop them in. So I do not leave a gap in it, because I guess it interferes with fitting stuff in there later, and just kind of getting everything in the right orientation later on becomes trickier. As you can see, the LEDs kind of extinguish and when you stick them in there, because they're not fully contacting anything yet. But if you just simply put your finger on the back of them, you'll see that they're still lighting up. If you want to make sure that every port's working as you're doing things. And I'm going to put all these in real quick, and then we will get back to the soldering portion of this. All right, now that I got all of my LEDs placed in there, I made sure they're all blinking and they're all working. I'm going to go ahead and solder that one edge. Now, the first time I did this, I just laid a piece of tape over the top, but it kind of made the pins kind of mismatch, and somebody recommended to me to use your bezel on it, and then you just kind of line them all up right in there, and then make sure it's up and down right there, and then I'm just going to secure that with a piece of tape. And then that'll ensure that all my LEDs are, that they're all lined up, with the bezel at least. Upon thinking about this, I'm going to need another piece of tape. See how well this method works. I think some people will line up all the LEDs and solder them all in at once after getting them all in. I don't like that because you don't have really a whole lot of control over
over your soldering iron at that point. You lose a lot of control when you lose that surface area. All right, well, I think that's probably about as good as it's going to get. All my LEDs are all lined up on the inside, and I think they're for the most part pretty straight. So what I'm going to do is I'm going to now use my actually I'm going to use my solder in my helping hand over here. Kind of point that into a good position, heat up my soldering iron, and then we are just going to continue soldering the same way we were soldering before. It's just a lot more tedious because we now have a lot of LEDs to solder in. So kind of solder through parts of this first row, probably speed up this video, and then I'll show you guys what it looks like when I get there. Would probably help if my soldering iron was hot enough. There we go. So now take your time with this. Some people said that it took them a really long time to just solder in a couple rows. If that's the case, that's fine. You know, take this at your own pace. It's not a marathon, or it's not a race. It's more of a marathon. You just got to get through it. It's a little tedious at points, but find something good to listen to. Find a good podcast or an audio book or something. You kind of make it through this a little easier, and you'll find some parts are a little easier than others. So one actually good thing to do that I didn't do just now is turn everything off. Especially if you could possibly bridge anything. You really don't want to bridge something while it's powered, and we don't want to fry any of our electronics. So as you can see, I am no expert at this. I kind of just find the way that works best for you, and go from there. You may find it turning a different angle on something may help a little bit as well. To get a better vantage point. Yeah, see, I'm already doing a little better right here just from changing the angle I was soldering at. Okay, I got all the first row on. I go ahead and booted it up, and all of my lights are blinking as intended. So that is one successful row. That row took me maybe 5 minutes or so. May take you longer, may take you less time. It's not a competition. As you can see, they're all blinking, and they all look like they should. No lights out, no over powerful lights. Sometimes the cheaper quality LEDs, maybe they'll mess up the short lead, you know, so you can't quite tell which one's the positive and negative, and sometimes that'll just be wrong. So maybe you'll see one in here that's not blinking right, or it's way too bright. If it's reversed, it'll be much brighter than the rest of them are. But these all look pretty good, which is what I've expected. I've only seen one bad LED. So I'm gonna go ahead and turn that off, and then I'm gonna go ahead and clip all these down. Now the reason why I don't do all of them at once as well, other than it's just harder to get into, is it makes it a whole lot easier to clip these suckers. And you could use, you know, a pair of flat cutters or something like that, but these, you know, 99-cent fingernail clippers work real well, and everybody has a pair of these, and I didn't want to go spend 12 bucks on a new tool, which I probably need one anyways, but you know what, hey, this works and I had it. So we'll go ahead and clip all these down, and then we'll start on the next row.
All right, well, that didn't take too long. We got all the LEDs all in here, lined up pretty good, snipped all the back. During part of that hyperlapse, I actually forgot to clip a row before I put the next row on, and that was significantly more difficult to get them clipped off with another row on. So I would definitely suggest before you move on to each row to make sure you clip the backs of each of the LEDs and get off the extra bits with the nail clippers, because it's significantly easier. So now that we got it all on, go ahead and boot it up. Here's its boot up sequence, and you can see my name and all the lights are flashing. And that is the that's that for the RLD. In the next one, I'm going to be doing it. The video is going to be a lot shorter, but I'm going to be doing both of these guys. The gosh, I always forget the name of these darn things, but I'm going to be doing this guy as well as the power state indicators, or the PSIs. FLD, yeah. I'll be doing the FLD and the pies. So if you enjoy the content that I'm making, go ahead and give me a subscribe. Maybe someday I'll make enough videos and make some quality stuff where I can monetize the channel. But I enjoy you guys sticking around. If you guys got any questions, shoot them down in the comments. I'm pretty good about getting back to you in a timely manner as long as I am around. So yeah, if you have any questions, comments, you want to see anything else specific, let me know. I'll reach back out to you and get whatever information you'd like on these things. If you want to see some more of my R2 build, maybe I'll start doing some of those videos. I've pretty much finished printing everything. It's a lot of assembly, a lot of body filler, a lot of sanding. So, but if you guys want to see some of that, just let me know in the comments. I appreciate you guys sticking around. I hope this was informative. And go ahead and check out the next videos if you guys want some help doing the other lighting on the R2 dome. All right, Big Pete out. Thanks, guys. Oh, and P.S. I would like to drop another thanks over to Paul M., John Vannoy, and as well as Devin Olsen for their contributions into making this happen. This is just such a fantastic product. It's so easy to build. It's cheap, relatively cheap when it comes to R2 building. So thanks again, guys. I appreciate it.